The thing I wanted to talk about today was about embedding magnets into your laser cuts. I tend to do a lot of these. Let me show you. I tend to use these kind of magnets on stuff I make. And so the idea is that you want to be able to like cut a hole where the magnet fits nicely. They come in many sizes, but I got these online, and they are advertised as being 10 millimeters by 3 millimeters. So the 10 is the diameter, and then 3 millimeters thickness, so that roughly fits like a 1/8 inch plywood. And so the whole idea is that like I want to cut a hole that is just big enough that it fits into the plywood, and it has like a nice press fit. And so there are like some easy ways of doing that with Cuttle. So there are some easy ways of doing that with Cuttle that I wanted to discuss, because like they are like, the options are kind of like, by showing you how to do the magnets, then hopefully you'll be able to do other things, because you do a lot of testing when you're laser cutting. Like you could test slots or other things like that. So I think let's get started with the presentation. So I just have a blank project here, and I'm gonna call it just, I'm gonna add the title, so embedding magnets. And so I think the first thing I went ahead and did was it says that it's 10 millimeters. So I just went ahead and cut a 10 millimeter circle. I'm working in inches in this particular case, but I'm gonna start with just that circle. And even though the whole project is in inches, sometimes you can actually just type millimeters. So I'm gonna change the scale of the circle to 10, and I'm just type millimeters. And so it auto, it calculates and it turns it into inches, so you can see the result right here. And then, if I cut a hole, I want it to be kind of supported by something. So I just did a rectangle, and I made that rectangle just 1 inch. So if you're doing these, you might want to use less material, but I just went with 1 inch because it seems like a nice kind of round size. So, and I made that red because I want this to be the inside cut and this is the outside cut, just to distinguish it. So what I did is I just went ahead and cut the 10 millimeter one. And so here it is. So I just cut one, this is a 10 millimeter hole, wishful thinking perhaps. And so, because then when I went ahead and tested it, let me just zoom in a little bit. So I just went ahead and tested it, and like I put the magnet in, and it was looking good, except it just kind of goes through the hole. So that wasn't good enough. So then, of course, at this point, I was like, okay, maybe these things are in 10 millimeters. Exactly. So I came with my calipers, and I started measuring it. So let's see. Let me turn it on. I want to zero them at that point, and I measured it. So with the first one I did, I was like, oh, okay, 3.96 inches. That seemed to make sense. So I went ahead and cut another one. So I went back to my cut I had right here. I'm just gonna give it a name. I'm gonna call it 10 millimeters. So I just actually, instead of 10 millimeters, I just did I changed the scale to 0.396 inches. I'm gonna switch to inches now, because just to keep it consistent. So for those who just got here, the recap is that I'm trying to embed, the goal of today's live stream is to make a hole where I can embed a magnet. So because sometimes it's nice to embed magnets in some projects where you can like put them on your fridge, or like you can use them for closures or things like that. But like right now, I just want to like use Cuttle to help me test different holes, so I can embed the magnet the way I want it. So yeah, the first thing I did is that the magnets I bought were 10 millimeters, allegedly. So I just went ahead and cut a 10 millimeter hole, and then when I put the magnet on, it didn't go through. And so then the next step was to, of course, go ahead and like measure it with calipers. So I measured the magnets with these calipers, and I was getting like 3.96, 3.94, but I kind of just went ahead and cut I did this circle with 0.396 inches, and I actually went ahead and cut that one. So I have it right here. So this is the new cut. This was the 10 millimeter one, and they're so similar that I actually just ended up just labeling it with pencil to know what I had. And so this is a 3.96. I went ahead and tested it, and actually not quite there. And if I test other magnets, because like at this point I was kind of realizing that there are different sizes. I mean, they're not like super precise. Maybe it's the quality of magnet that I bought. But definitely 0.396 inches wasn't the thing. So I went ahead and labeled this one 396 inches. And so what I realized at this point is that, of course, I need to make multiple cuts. And so this is where Cuttle becomes kind of handy, because like I can actually create a component that has like multiple cuts. And so that's what I did next. So let me show you how I started doing that. So I'm just gonna leave this one that was my first test over here. I'm gonna create a new component, which is gonna look quite similar. It's gonna have a circle. I think the next one I wanna try is 3.96, so less than that, it's 3.95. So I wanna try that. And then I just went ahead and did another rectangle. That was 1 inch. I made it red, so it's just a different cutting operation. But as you saw, I was just labeling things with pencil, which is totally fine. But why not label them with a score? So I decided to start to grab the single line text. So if I browse all shapes here, I can look for single line. The idea of single line text is that because it's a single line, it will score faster, and these fonts are still kind of readable. I like this readability font. I think that's kind of nice. Definitely make it smaller. Something like this. And then just bring it down a tiny bit. I'm just doing it by changing the y-axis. Yeah, maybe like this. All right, so my goal here, and I'm gonna give it. I'm gonna change the color so I can assign the operation to be a score. So I'm gonna do blue. So my idea here is that I want these holes to be labeled with the size. So in order to do that, I'm gonna create a parameter here, and that should be just the size or the diameter. And I want this parameter to drive both the size of the circle or the scale and the text. And so let's start with the circle. So essentially what I want to do here is kind of plug in this diameter into the scale. And so let's start with the scale that I wanted, 0.395 inches. Yeah, I can leave it at that. And so in order to plug this in here, I can click here and then just type diameter. And just to check that it's working, now I can just like change this diameter. I can drag it, and so the size of my circle changes. Let's go back to 3.96. So that makes sense. Now I need to plug in this diameter into the text. So the idea is that this value drives that text. So let's do that. In order to do text, if I were to type just diameter, then I would just get the word diameter. But because this is a parameter name, in order to kind of meaning it's a variable or like a little box where I'm storing a value, then I need to click on these 3 dots on the right and hit edit expression. And so now you can see that the word gets into quotes. So I can just type diameter and it actually gets autofilled there. So that's a good sign that things are working. All right. So if things are working at this point, I should get the whole to change and the number to change when I just change the diameter. All right, so that's good. So I know this seems like a lot of work for just the whole. But I think now that I have this setup, I can actually easily make variations. So I'm going to call this one the variable whole. And so now what I can do is I can just start another component. And then if I drag instances of this variable whole here on the canvas, or like the workspace, if I drag different ones, then I can actually change their numbers. So like, let's say I want to cut the, 396 is the one I cut before. So I want that 395. So now I just need to do that. Then I want another one that is 394. Then I can do that. Then I can drag another one that is 393. Maybe those are two small variations, but like, so at this point I think I have a good setup. Like I can cut multiples of these, maybe a 392. And so at this point it's cool because I can make variations. I can confirm that this is working because whenever I exaggerate it, you can see that the whole and the number change. So now at this point, I can simply just grab all of these and send them to my laser cutter. And that's exactly what I did. So let me show you. So I cut them like so. Maybe in order, 394, 395, 393. So I guess the beauty of this setup is that like I didn't have to label it with pencil. They're just kind of labeled for me by the machine. And so now I can go ahead and like test each one of them. So I think the increment was quite small in inches. So let's see. That one doesn't quite work. If they go straight, like the 393 started to like have some purchase to like kind of hold onto it, but it's kind of easy to push. Actually, it's kind of decent with this particular one, but let's see, let's try other magnets. Yeah, others just kind of like fall. So yeah, there's some variability of magnets. 392, yeah, somehow that one didn't work. That one kind of didn't work. So anyway, I did my tests with these, but I was like, not good enough. Let's just make more tests. So for my next round of testing, the thing I wanted to do was, I mean, they're fine if you cut them in like small pieces, like the small pieces I cut like these, if you want to have them floating around, but maybe you don't. So this was my next version. I wanted to do like, I'm just gonna get a new component, and so this is what I did. I did the same kind of variable thing, and the next one I wanted to start at 391. So 391, but I just wanted to cut it in a single piece, and so this is what I did. Perhaps still tricky because like let me tell you what the situation is here. If I put them like that and I apply a Boolean union, which is kind of like the natural way, then the inside part kind of disappears. It just kind of treats all the shapes the same. So I didn't want to do a Boolean union, I just couldn't. So what I ended up doing is something like this. I just grabbed all my pieces and I just kind of snapped them to the, and then I did the numbers. So 391, 390, um, 389, and 387. And so essentially, I just grabbed a rectangle, which I want to be my outside cut. I made it just the size that was. And then I just went to my original component and I got rid of the original. I don't have to get rid of it. I don't have to delete it. I can simply make it invisible, or hidden. And so now that rectangle is hidden, but then in the cut, then I get the outside rectangle to match. So it's not the most elegant way of accomplishing that, but it works. So also, if you're not familiar with scores, like we want to set all these to cuts, but then we want to set these to score. I'm not looking. Okay, maybe I'll show you. So the idea is that, because there are different colors, there are different operations, and a score is when you, it's kind of like a cut, but it's at a lower power or at a lower speed, so it doesn't go all the way through. So once I had these, I just went ahead and cut it as a single piece. And here it is. Here's my quick test. So I don't know, maybe a single piece a little bit more manageable than a bunch of floating pieces. The advantage of the floating pieces perhaps is that you can use a bunch of scrap to do your testing. Kind of up to you. And so once I had these one, I went ahead and tested all the different sizes. So yeah, a little nicer. Just want to test them all. Yeah, I think the magnet variability is kind of intense. Like you can see how this one is a little bigger. So I think I wanna reach a size that kind of works in general. So I can I don't mind pushing it really hard. So that looks decent. Let's test it with another magnet. This one is okay. Feels a little loose. Let's test it with this one. Yeah, that's all right. I could be happy with that, with this particular magnet, but I actually wanted to make more cuts. So I think at this point, at this point with the project, I could simply be happy with it. Because sometimes you just want a number. You just want to find the number that works and go with it. Just not fuss around. And so if you had enough at this point, I think it's perfectly fine. I think this is good. But I didn't. I kind of wanted to optimize it a little bit because what if I want to test other different magnets? Then I have to come in here and change all these different numbers by hand. Also, another caveat I wanted to mention is that in this case, I don't care about curve. I'm I want to be this is the number I typed. This is the hole I get. I'm kind of ignoring the idea of curve altogether. I say that because then, at the end, the hole that I get, this hole is not precisely that size because the laser kind of burned away more than the size. So if you're into more hardcore precision, we can talk about that, but this is not this is not exactly what I'm doing. That's just the little caveat. So I'm just treating it as I want to find that number and move on with my project. But yeah, the little refinement I wanted to do was I wanted to be able to just type a number and kind of type an increment and go from there. So I'm just gonna show you that refinement. I hopefully it's not super complex or complicated. But maybe it also gives you ideas about how some of these other templates are made. So I'm just gonna create a new component here. And so the idea is something like this. I wanna use that same hole I call it my variable hole. And I could even bring that rectangle back in so we can see it. And so the idea is that I want to create I want to repeat it. So to create a repetition that goes across, I can go to modify, and then there is this one called the linear repeat. And so the linear repeat just repeats them with a certain spacing. In this case, the spacing is 1 inch. I could make it smaller or bigger. And it creates the number of repetitions that I tell it to. So I could create like, 6 or 5 or anything like that. So far, so good. This is just like, we're repeating things. It's kind of like cloning them. But then I want each of these numbers to be different. And so right now, if I just change any of the numbers, it changes them all. You can see how they change. So you can see that. So it changes all the numbers. So I wanted to change them individually. So this is where this little cool thing comes in. So when I click on the linear repeat, there is this option that says customize each repetition. So if I click on it, then it creates this new set of numbers right here. It calls it rep, or the index variable. And so what that means is that the index variable assigns these number, to each one of these repetitions. So the original one, this one, it calls it 0. Because it's just the original one. Then, and that's kind of like how programmers tend to think about these things. Then this one, it calls it 1. This one, it calls 2. This one, it calls 3. This one, it calls 4. And also that rep variable, this one right here, becomes available for me to use. And so I can use it in funny ways. Like, for example, if I use the diameter and I simply type rep, then you can see what happens. It made a hole that is 0, so no hole. It made a hole that is 1 inch. It made a hole that is 2 inches. It made a hole that is 3 inches. It made a hole that is 4 inches. So that's cool, but not what I want. I actually want something. So I'm going to tell you the math, and hopefully it's not terribly confusing. So I want to start this at 0.386. So that's like my starting point. And then I want to add something to it. So I'm just going to type plus over here. And I could add rep. So if I add, that rep, then what I get is that it added 0 to this one. So that's fine. But it added 1 to this one, added 2 to this one, added 3 to this one. So not entirely what I want yet. I want like an increment amount. So let's say I want to increment it by, I'm going to put it in parentheses, 0.001. So now if I were to multiply that increment amount by that rep, so I'm going to just multiply it, then you can see that let's look at it. So to this one, it added nothing because it's, let's look at it. To this one, it added nothing because it's 0.1 times 0, so nothing. So to this one, it added 0.01 because it's 1 times 0.01, 2 times 0.01. And so that's the logic of this particular project. And just to make it more understandable for myself, what I wanted to do is I wanted to have like a starting point, which in this case was 0.386. And I wanted to have, it's not an increment, in fact. I want to decrease it. Decrement? I don't think that's a word. Reduction. I want to reduce it by 0.001. So now that I kind of got the math and the logic figured out, I can just replace these here, and I can replace the reduction here. But because I want it to be a reduction, I just want to subtract it. So I'm going to subtract that. So I want to do a starting point, and then here is the reduction. I'm just kind of substituting things. So So this is what I ended up with. Like I did the starting point. So now you can see that if the starting point changes, everything changes. So that's good. And then if I change the reduction, let's make sure it's reducing 386, 385, 384, 383. Yeah, cool. I can change that too. And kind of like the final touch with this one is that, yeah, once again, I have the rectangle. So maybe that's not ideal. I'm gonna hide it. This one. So maybe I actually want a rectangle here that it just expands with the number of repetitions. So I don't know, I have 5 repetitions, so it's 5 inches. Yeah, let's do that just to finish it off. So I think the idea is that I want to have repetitions. Right now I have 5, so I can substitute the number of repetitions on the linear repeat, so those repetitions. Then this rectangle should be, the length should be repetitions. And now if I change that, yeah. One little change here is that this rectangle is expanding from the center. So it has a transform center. So I want it to expand from this point. So when I have the rectangle selected, I'm going to hold the command or control, and I'm going to change the transform center all the way to this point. And so now whenever it expands, it should expand to the right. So yeah, I could do any number of repetitions here. And that's basically my tester. Just to show you the final cut I made with that. So started at 386 all the way to 382. A little harder to push, but I think that's nice. I think if it's a little hard, I can actually, maybe that's too much. I can actually push it in. If I push it really hard, I can get it to stay. Sometimes I will add a little drop of super glue in the back just to like make it stay. But I think this is hard enough that it's like pretty good. So that is roughly how you could go ahead and create something like this for yourself. I think you're not limited to holes. You could try notches or things like that. But the kind of quick tester I created for myself also allows me to do way smaller magnets. It's like, let's say I have like I have this tiny these tiny 3mm magnets, and I did something pretty similar to find the hole that I could embed. I could use to embed the magnet in. So with the tester I just kind of created, the beauty is that I can be like, oh, the starting point should be, I don't know how much that is, 0.2 or something like that. And now I can just go ahead and cut these and I have like an easy way to test it. Just to finish it off, like if you don't want to make, I wanted to do this so you could make this kind of tester for yourself, or use this as a model, but other people have made interesting things. Like, for example, Hannah made this magnet tester. I'm going to put the links of these in, later in the description, which by now you can kind of understand how it works. Hannah actually added the curve if you want it, but if you want to ignore that, you could just make it 0. And so with this tester, you can change the diameter that you want to try to embed your magnets, change the increment, kind of like the same way we did it before. And then what she did is that she made it so it's a hole, but then you can also engrave different colors. You can kind of engrave a bunch of colors if you want. This is a really neat tester. I really like it. So because sometimes you want the hole engraved for your magnet, so you can just like place it right there. So that's one version. The other version that I made at some point is that sometimes I do the same thing for holes that I want to put screws through. And so there is this one that lets you create a number of holes. I made it in millimeters. So it's similarly, I get like a starting point and then an increment. And so you can, this template is not perfect. I think it's like, it could use some development. But as you can see, it creates a bunch of holes. You can change the number of rows and columns, and the spacing, importantly. So yeah, so I think, thanks for coming. Hopefully that was interesting or useful. And I will see you in the next one. All right, bye.